As promised, I've made a little video to practice finding values of sides of triangles when they're a special right triangle. So there are two special right triangles in math. One of them is a 45-45-90 triangle. It's so called because it's a right triangle where the two acute angles are both 45. Since those angles are equal, the sides opposite them are equal. And so this side equals that side. This leg equals that leg. If you do the Pythagorean theorem on that, you'll find that no matter what you get, you'll always have the hypotenuse be that leg times the square root of 2. Now, the other special triangle is a 30-60-90. It's again a right triangle. It's got an acute angle that's 30 and an acute angle that's 60. And you can check that those angles add up to 180. In this case, the shortest side, whatever it is going to be exactly half of the hypotenuse. And the leg, the longer leg, which is opposite the 60-degree angle, is the short leg times the square root of 3. Now, part of why these triangles are special is because they are half of other important shapes. The 45-45-90 is half of a square, and you might be able to see that it's cutting diagonally from corner to corner. The 30-60-90 triangle is half of an equilateral triangle. And you might be able to see that if we drop an altitude up and down in the middle of our equilateral triangle, it splits the base in half, and I have two equal triangles. Because it splits the base in half, that's why this side here is exactly half of the full length of the side of an equilateral triangle. So that's where these originate. That's part of the information you need to do the proof of these relationships. But these relationships always hold. And if you haven't written these down in your notes yet, you need to pause the video and write this down. So now I want to practice this with a whole bunch of practice problems so you can see how the pattern is helpful, so you don't need to use trig to find the other sides. So suppose I have this triangle. It's clearly marked as a 45-45-90. The first thing I'm going to do is locate that right angle, and the side opposite is the hypotenuse. If this side is my hypotenuse, then the other sides are legs. The legs touch the right angle. Well, we know that in a 45-45-90, the legs will be the same. So if this side is given as 6, then the other leg is also 6. And the hypotenuse is just the leg times root 2, so my hypotenuse is 6 times the square root of 2. Let's do that again. In this case, I'm only given one angle that's labeled as 45, but we can do the math on it. And since the angles of a triangle add up to 180, this other angle would also have to be 45. And if two angles of a triangle are equal, then the sides opposite them are equal. So once again, the legs of my right triangle in this case, since it's a 45-45-90, the legs are equal, so this side is also 45. The hypotenuse is across from the right angle, so it's a leg times root 2, so my hypotenuse is just 5 root 2. I'm using the pattern. I'm not actually doing any calculations. Once again, I have a right triangle. I have that this angle is 45, so that one must also be 45. So this is a 45-45-90. In this case, I am given the side across from the right angle. It's 7 root 2, and it's the hypotenuse. We know that the hypotenuse is always the leg times root 2. So if this is 7 times root 2, that means that the leg must be 7, both of them. Again, here's my 45-45-90. Here's my right angle. The side opposite's the hypotenuse is 100 root 2. Don't be scared by the big numbers. 100 times root 2 is just leg times root 2. So each of the legs in this isosceles right triangle must both be 100. Now you have this pattern rule written down somewhere because I'm going to cover it up as I show you more practice problems. Now, what if my leg is an ugly square root, an irrational number? Doesn't matter. The legs are still the same in a 45-45-90, so this other leg is still the square root of 11, the same as the other leg. They're both the same. My hypotenuse is going to still be leg times root 2, so it's going to be the square root of 11 times the square root of 2, But since they're both irrational numbers, we can perform the operation on them, and that will equal the square root of 22, to simplify it. Now, sometimes they won't label them as 45, but you need to recognize that this is isosceles because the two angles are marked as equal. And since that's 90, and we've only got 90 left, we'd split it evenly. Those would both be 45s. So this is still a 45, 45, 90 triangle. And so the legs are still equal. The legs are the sides that touch the right angle. So if this one is 8, the other one is also 8. And the hypotenuse, which is across from the right angle, don't be alarmed by the fact that it's turned around. The hypotenuse is going to be a leg times the square root of 2. Now, sometimes you might have fractions. Again, this is a 45, 45, 90. If my leg is a fraction, 1/4, the other leg is the exact same fraction. And the hypotenuse is just that fraction times the square root of 2. Same pattern. You might be given some really intimidating looking fractions that are of irrational parts. This is 7 times the square root of 2 over 2. Don't worry, the other leg is going to be the exact same thing. You don't even need to think about it. The legs are the same in an isosceles right triangle. The hypotenuse is going to be a little more work. It's going to be this number times the square root of 2. So it's going to be 7 times the square root of 2 over 2, the leg, that's the leg, times another square root of 2, this time over 1. And my root 2 times my root 2 will multiply together, and the square root will undo itself, so I'll just have 7 times 2 over 2. Well, that's 14 over 2, and 14 divided by 2 is 7, or you could just say to yourself, oh, my 2 on top and my 2 on bottom divide out, so my hypotenuse is just 7 in this one. A nice, pretty number 7. What if my hypotenuse is given in this 45, 45, 90? I know that's the hypotenuse because it's across from the right angle. That number is equal to the leg times root 2. Well, let's just let our leg be a variable for a moment. This leg is x and that leg is x. They're the same. X times the square root of 2 is going to equal 1. I solve that equation by dividing both sides by this number. So x is going to equal 1 divided by the square root of 2. Now that is the answer, but we're usually not allowed to leave a square root in the denominator because of how it will affect computing things. So we rationalize that denominator by multiplying the top and the bottom of the fraction by the irrational that we have in the denominator. This is an irrational root 2, so I multiply by root 2 over root 2. That'll make my denominator a nice lovely 2, which is a rational number, and I will have my irrational on top. So that'll just make it easier for the computer to do the computations. So my leg over here is root 2 over 2, and this leg here is also the square root of 2 over 2. This one is actually an important triangle to know. One more. Do not be alarmed if your triangle looks like it's upside down. There's my 45, my 90. These are my legs. So what's this leg? The same as that leg. How about my hypotenuse? It's going to be the leg times root 2. So it's going to be this value times the square root of 2. But root 2 times root 2 gives me just 2. And 3 times that gives me 6. So this is another example, like this one, where my hypotenuse works out to be a nice, lovely number, and my legs have the square root of 2 in them. Now let's look at the other special right triangle, the 30, 60, 90 triangle. And this one's a little bit hard. You have to pay attention to which angle is which. The legs are not the same. This one has this rule where the relationship, as we described earlier, is the shortest leg is the side opposite the 30. That's half the hypotenuse. And if I take that short leg and multiply it by root 3, that's what I get for the side that's opposite the 60. Doesn't matter which way the triangle is turned. So I've written a little rule right here so we can see it as we're doing our practice problems. The first thing you want to do when you see one of these triangles is recognize that it's a special right triangle because it's got a 90 and a 30 and a 60. So we call it a 30, 60, 90 triangle. Then you want to identify where's my hypotenuse. My hypotenuse is across from the right angle. So if this is my right angle, my hypotenuse is here. Then you want to see what side am I given. I'm given this side. It's across from the 30. Well, that's the shortest leg. That's the shortest side. It's exactly half of the hypotenuse. So that means that my hypotenuse is 2 times 15 or 30. And my longer leg, the side opposite the 60, is just the short leg times root 3. So in this case, it's going to be 15 times root 3. So the challenge here is to figure out which side is opposite which angle. Let's look at this triangle. I have that 7 root 3 is across from the 60-degree angle. Well, the angle 60 is across from the short leg times root 3. So if that's short leg times root 3, that tells me that my short leg is just 7. So that the short leg is 7 and the long leg is short leg times root 3. Remember, in the 30, 60, 90, we get the square root of 3 gets involved. The hypotenuse is the side opposite the right angle. It's double the shortest leg, so it's 2 times 7 or 14. Let's do another one down here. Suppose I'm given the hypotenuse, and I can tell that's the hypotenuse because it's across from the right angle. The first thing I'm going to do is I'm going to find the shortest leg, because the shortest leg is just half of the hypotenuse. Half of 20 is 10. Once I know the short leg, the long leg is just the short leg times root 3. So it's going to be, in this case, 10 times the square root of 3. That'll give me my long leg. Let's do this one. My side that I'm given is 11, and it's across from the 30-degree angle. So it's across from the smallest angle, so that's the shortest side. The shortest side is half the hypotenuse, so the hypotenuse is going to be double the 11, or 22. And the long leg is just the short leg times the square root of 3, so it's 11 times the square root of 3. Sometimes you'll be given a number that's not a rational number. My short side here is the square root of 5. Well, it's still the short side, so to get the hypotenuse, I'm still just going to double that. So the hypotenuse is going to be 2 of those, or 2 times the square root of 5. My long leg is going to be the short leg times root 3. So it's going to be root 5 times root 3. But since they're both irrational, we can simplify it by multiplying the radicands, the things inside, and that'll get me the square root of 15 is my long side. That would be the simplified way. Do not be alarmed if your triangle appears to be upside down. Still, find yourself, locate your right angle, find your hypotenuse, locate your smallest angle, find the side opposite. In this case, the side opposite my 30-degree angle is 1. My hypotenuse is just going to be double that. Double 1, you get 2. My long leg is just that side times root 3. You could write 1 times root 3, but we usually just say root 3. Again, this one is turned around, but I can still identify that this side is my hypotenuse. So the first thing I'm going to do is figure out the shortest side, because the shortest side is just half of that. And I can divide 100 in my head. I get that my shortest side is 50. My longer leg is going to be across from the 60-degree angle, is going to be that length, the short leg, times root 3. So that's just going to be 50 times the square root of 3. And there's your answer. Now this one is a little harder because we're going to have to deal with fractions. In this case, my hypotenuse is 1. It's across from the right angle. The side opposite the 30-degree angle is going to be half of that. And while I know many of you would like to write 0.5, I'm going to really encourage you to write 1/2. The side opposite the 60-degree angle is the short leg times root 3. So it's just going to be 1/2 times the square root of 3. But we usually write that square root of 3 over 2. It's the same thing, really, but you'll see it written this way more often. So this last example is probably the most famous 30, 60, 90 triangle that you will see.